Niels Falk is the CEO and head of consulting and innovation at HD Lab. It's a consulting and technology company who are based in Denmark, but as I understand now working worldwide. So Niels, with that, please feel free to begin.
Thanks a lot, Daniel. Thanks for having me. So much cool stuff coming up today. I feel a little bit like I showed out about gunfight with a butter knife. So I hope I won't disappoint you with what I brought for you guys today. As Daniel mentioned, we work mostly out of Copenhagen in Denmark, and we help projects with technology. So we work in the trenches of the projects with design and planning and laser scanning and documentation and supporting them. And amongst other stuff, we of course work with automated modeling or generative parametric design, and we've been doing that for a couple of years. And mostly we've done it to kind of speed up the modeling, or to get free detailing, or to fix problems in the model. So it's been a lot of stuff like this when we've been tasked to model existing buildings. They are not always completely straight, so we needed a number of scripts to be able to do pipes that curved and ladders that and staircases that weren't perfect and all that. Maybe it's important to know that 1/3 of the construction in Denmark is renovation and refurbishing. So it's a little bit important to be able to model these things. Also, we've done a number of scripts that fixes problems. This is from a big hospital project in Denmark, where we built a script that fixes clashes between installations, MEP and walls. And every 2 weeks, this script goes in and spends 6 hours cleaning up this model and punching somewhere between 55 and 80,000 holes in the walls to accommodate for the installations. So and the last one here is a geometric optimization of a land use problem, where we tried to see how much real estate we could fit into a piece of land under the existing codes and guidelines, trying to find the optimal there. So this is a lot of geometry, to be quite honest, that we've been looking into, and we don't throw the scripts away. We work industrialized as well. When we fix a problem, we actually keep the scripts for future use. And then something interesting happened maybe over the last 18 months, to be quite honest, in Denmark, where we do most of our work. Sustainability became not just a big thing, but a really big thing. So there were 4 agendas that moved in on us, and one of them was the UN sustainability goals. Another one was eco-labeling with GGNB and the Nordic eco-label of buildings that kind of goes to environmental performance of buildings. The third thing was that the government actually sat us all down, and every industry in Denmark, and had the industries make a CO2 plan for how to reduce the carbon footprint with 70% over the next 10 years. The last thing is that there's been a huge focus on circular construction and design for disassembly. So the interesting thing about this from a generative design point of view is that all of a sudden we're outside just fixing geometry. This was a game changer for us. We needed to work a lot more with the data, and at the same time, these 4 things are actually not necessarily agendas that help each other. They can be very conflicting agendas to work with. So it became very complex question how to design and schedule the buildings. And with the complexity of the question, we started trying to solve that with some more complex stuff. So I have a couple of case studies that we've done over the last 12 months that I wanted to show you guys, and share what we've learned so far. So the first one here is where we took our land problem and took it to the next level. Here we started working with the data on the land optimization and the code zoning, and started feeding in also daylight data and shadow and all that kind of stuff. So it took us together with the architect and the building owner into trying to optimize not just the volume, the area used, but also the overshadowing of the buildings. And we kind of ended up in a kind of iterative process where we went from about the 12 million alternatives into 4 that we used to kind of find the optimal solution for the project. So we found actually a lot of square meters and a lot of daylight in this exercise. The other one I wanted to show you here is we built a configurator for a wood building system called Cree. We made Modulo. So it's a configurator that allows you, based on some parameters, to generate a 3D model of the load-bearing structure made in CLT in this case. So you basically tell the system, you know, how high the building is, how many floors you want, and all that, and it will generate a 3D model of it. And this is actually just taken from my screen earlier. So this is how long it takes for us to generate a construction, to generate the project. Is a couple of seconds. We have different types of buildings: towers, linear blocks, perimeter blocks, and we have these different parameters. And what's really useful for this is that not only do we produce the design very quickly, but it's also, as Ian mentioned, it's buildable and it's feasible to build. So it gives us speed, and it gives us the ability to explore a lot of alternatives quite quickly. And at the same time, we can actually do a measurement of what's the component price and what's the CO2 lifetime emittance on the solution we have, and kind of compare different solutions to this. And we know it's built together by parts that fit together, and we know that we can buy all these stuff in maybe not the supermarket, but at least from companies. So it also takes a lot of the offsite construction to a faster decision-making process, and allows us to make some good decisions on that. The architects were a little bit concerned about us forcing them into square shapes, so we also made a script that allows you to do to make it from freehand drawings, more or less, just to make sure that not everything ends up in a box shape. It should pop up any second now. So it's it gives us only legal solutions within code and within the building system. So the next level we've worked to this is trying to optimize these choices with a lot of different types of parameters. Here's a new set of buildings in Copenhagen called Vejlandskvarteret, which is also wooden buildings. And there was a ton of codes and a ton of environmental requirements. And it boiled down to a number of different parameters that needed to be optimized at the same time. And the architects, Henning Larsen architects, had been working on a number of different ideas for this, and we came in and helped them to script this together. So all the ideas we could explore them and not make illegal solutions. So we ended up doing a score for a couple of different parameters. And we ran a number of simulations to find what was the optimal when it came to wind, daylight, lighting, density, and view, and a number of other things. So we kind of put it together in an overall score, and could kind of optimize the project based on that. So this is another project where we took it a bit further. Here we also started looking at not just the optimization of the geometry within the code and the regulations, but also optimizing how many types of different apartments you would get in a housing project like this. These are affordable housings, so everybody wants to give these people as many square meters and as good apartments as possible at a minimum environmental footprint. So we're trying to optimize the geometry. We're trying to optimize the apartments. We're trying to optimize the layout of the apartments. And at the same time, we can see in the bottom, not just the environmental footprint for the construction project, but also we did it for the maintenance. We did the math on that as well. So you can kind of see how different solutions and different positions would change the environmental footprint. And at the whole time, it's checking up against the building program. So again, we're in this, that all the alternatives that we look at are within the specs of the zoning and within the specs of the client, and we can then iteratively find the solution that's the best environmentally. So once we've done that, we go into the use of the building, and here it's an office building that we have optimized for use. So it has a lot to do with finding out, how many desks and how many meeting rooms and all that can you fit into the building within the rules of the company that's moving in there. So trying to find acceptable daylight conditions and meeting room coverage and all that. So once we solve the geometry, we can actually start looking at the use of the house. So we run these simulations to find the ones that gets the highest score to allow our customers to choose the best. We find that even when we find the one that scores the best, they may want to track down to something that has some choice that they like. If they like, it may not be optimal to have 2 very big meeting rooms, but it may be something they want. So working this way, we can cherry pick among the optimal solutions and find the one that's best for their expressed and maybe not so expressed needs. And that kind of took us into to the next level of this, which was trying to gamify this for the client. So we end up building this almost like a configurator because we found that one of the indoor climate and the sustainable aspect of this is very much dependent on also using the building in the right way. So if they can see themselves in the building and they can see the configuration of it, and they at the same time can see the implications of changing from one material to another, and from X amount of meeting rooms to less, both when it comes to price, indoor climate, and CO2. We can sit with them in a session, and they can optimize the building. This is crude as it is. It actually works for a lot of clients to do this because it's easier for them to understand the consequences of their choices when they can see them virtually, and when they can see the dollars and the CO2 footprint, than it is to look at a drawing and come up with a good solution. So we can check this against the solar, against the shadows, against temperature, against the length to the bathrooms, the distance to the bathroom, the distance to the fire escape, and that type of thing as well. So we get the utilization of the building as part of it as well. So we found that the adding of the sustainability agenda to this forced us to work in a much more disciplined way. Much of the discipline that my colleagues and pre-speakers have talked about actually gets forced upon us when we work with sustainability, because we need to work with metrics, and we need to have more data and more alternative, and we need to quantify the consequences. And it becomes a less emotional discussion, because if the numbers say this is bad environmentally and money and time-wise, then it's a bad solution. It also makes for a lot of balancing, which actually forces us to make some decisions earlier, to make more detailed plans, and to explore more choices. And last but not least, it leads us into automation, not just because of these automated tools being fantastic to explore a number of different options, but also because we need to go into more meticulous execution, and we need to stick to our industrialized plans. And that's actually one of the things we're battling a little bit with right now, is that we make up these wonderful optimized designs and these fantastic optimized plans, but we have a little bit tough time getting the builders to actually stick to the plans and build what's on the drawings. So we're not there yet. Yeah, so I have two small examples. Daniel, do I have time for that?
You have about 1 minute left, so
I'll be faster than a speeding bullet then. So we actually have started exploring using these generative tools to also make execution plans. So this is some earthwork where we use the generative design tools to kind of take the job apart and find the fastest way to move the earth. So it was actually to optimize it on a CO2 basis. So we routed the machines for earth moving and dynamic compaction based on the CO2. So rather than taking time or productivity into it, we did it on CO2, and it turned out to be a quite interesting lead indicator. We took off 18% of it there. So another case where we're experimenting with this is we work in this space as well, which is when you renovate something, you have to grind off all the old paint, and you have to, and that contains lead and all sorts of other things. So it's a horrible work. It takes a long time, and it's very expensive, and it's not very eco-friendly, to be quite honest. So somebody challenged us to build a robot that could do higher quality, less waste, less noise, and less dust, less CO2, and do it faster as well. And that's a horrible challenge, we found out. It sounded fun for about 5 minutes, and then we started having to fix it. But one of the things that actually helped us a lot in getting to where we are now was actually using generative design tools to optimize the cutting paths. So what we've done is we have this robot, and robots do exactly what you tell them to do, unlike carpenters and bricklayers. And we use the data. We have a ton of sensors on it that tells us the production data and the environmental data and the noise and all that stuff. And we feed that into a generative design script. Actually, yeah, it's a piece of Dynamo that we use for this, and it designs a program that takes the robot over the surface in the most effective way. So it's a little bit like when you have a blender, you can have a smoothie button or you can have a margarita button. And here we just have the generative design tool design these cutting paths. So this is not a commercial solution yet, but it's actually helping us a lot to improve these scripts for the production and to operate in very different input situations. I think that was my time.
Close it there, Niels.
Yeah.